Hello everyone. Welcome back to this session on Sutherland Hodgman. Yesterday I had shared with you the same notes wherein I had solved this problem. So let me just explain you how we are applying our Sutherland Hodgman. So here in the image, if you observe, we have a triangle represented by 1, 2 and 3. So this is representing our triangle, and that outer window, the rectangular or the square kind of window is our clipping window for performing our polygon fill area clipping. So now, if initially before initially when you're starting, so always start with the left clipper. So here, when you're considering when you're considering the left clipper here, so just see the first input list which I have taken is 1, 2 and 3. So the left clipper I have represented with a vertical line here. So now with respect to the left clipper you have to consider. Don't consider any other lines now. Your concentration will only be on the left clipper. So now imagine just that only one vertical line is there and you have a triangle. Now let us start observing each line segment now. So first line segment 1, 2. So where I have written here within the flower braces. So 1 and 2 if you're considering with respect to the left clipper, this is a boundary from inside to inside only. That is, it is not crossing your boundary of the left clipper. So that is we represent it as in to in, that is from inside to inside only, and both your points 1 and 2 will be a part of the output list. And next you consider the line segment 2, 3. So in 2, 3 if you observe, 2 is moving from right towards the left, wherein it is moving from inside to outside boundary. So one point in the while explaining the algorithm I had explained you all the various condition. So this is one such condition, that is outside inside to outside point. So 2 is a point which is inside, which is moving towards outside. So in this case what do we do is 2 is already a part of our output list. Now instead of representing 3 here, 3 has to be clipped and a new point will be represented here. We call that as 2 dash. So out of your line segment 2, 3, 2 is already a part of the output list, and now the new output vertex is 2 dash, that is which is intersecting with that left clipper. Now 2, 3 is done. Now consider your line 3, 1. So 3, 1 is a case wherein we are moving from outside to inside. So obviously 1 should be a part of the representation, and 3 we have moved it and we are calling it as 3 dash. So now after we have applied the left clipper, what is the output list of our vertices? You have 1 comma 2 comma 2 dash comma 3 dash. Now that is how your triangle will be looking like after applying the processing of the left clipper. Now next move to the bottom clipper. The image is now in this way. If you see, it has now 4 edges here which are represented 2 to 2 dash, 2 dash to 3 dash, 3 dash to 1 and 1 to 2. Now apply this to your bottom clipper. Now if you are considering bottom clipper, that horizontal line which you are seeing in the image, now 1 to 2, 1 to 2, what is that case? It is a case with when you're taking bottom clipper, this becomes from outside to inside. So 1 to 2, so 1 will be clipped and we are calling that new point as 1 dash. So what will be your output list of vertices? 1 dash comma 2. And next consider 2 of 2 dash, 2 to 2 dash, both the points are inside. So it is a case of inside to inside, in to in. So we are and since 2 is already a part of the output list, only 2 dash I have represented within the curly brackets here. And next, which is the line 2 dash to 3 dash. So 2 dash to 3 dash, what is the case? It is a case from inside to outside, into out. So 2 dash is retained, 3 dash is outside, so that is clipped off, and we have a new point represented as 3 double dash. And next is 3 dash to 1. 3 dash to 1 is a case wherein the line is totally outside, that is out to out, so don't consider that, forget both the vertices. So now what will be your new output list of vertices? You have a 1 dash, you have a 2, you have a 2 dash, and you have a 3 double dash. Now these 5 points will be the input to your next clipper, that is your right clipper. See the order I am going, go with the left, then go with the bottom, then go with the right clipper, and then you go with your top clipper. So now in the next image, what you are observing here, the right clipper is there, and I have written the image in this way. So with respect to the right clipper, actually all the points are a case of inside to inside only. None of the points are crossing your right clipper. In the first image only, if you observe, none of the points will cross your right clipper. So all the points which we got from the bottom clipper will be retained just as it is, totally without any change in the clipper. So if you look, if you observe your first image, you will see that none of the points are crossing your right clipper. In the same way, with respect to the top clipper also, none of the points are actually crossing that top line, so the same set of points will be retained. So after you have performed the clipping with respect to all the 4 edges, that is your right, left, bottom and top, the final set of vertices are as follows: 1 dash, 2, 2 dash, 3 double dash. And we had initially a triangle, but finally we are left with the 4 edges after we have performed the polygon area clipping. Okay, so this is how we have to perform. Whatever steps I have written, you need to follow the same format, whether it is from inside to outside, outside to, and here I have used this 2 dash, 3 dash way of numbering it. You can use any other way of representing the new vertex. You can use it as n1, you can call it as new 1, new 2, n1, n2, or you can call it as i1, i2, x1, x2. Whatever naming convention is not mandatory. You use 2 dash, 2 double dash, but it is better so that you will not get confused. And with this, I will give you also one more other problem. Even write that also, update that, and you check whether you are able to solve this problem of Sutherland Hodgman.